Sienna Weedman, and we are going to be working on FRQ 2013, number 3. So the problem reads, hot water is dripping through a coffee maker filling a large cup with coffee. The amount of coffee in the cup at time t from 0 to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. Part A says, use the data table to approximate C prime of 3.5, show computations that lead to your answer, and indicate the units of measure. So because in the table they don't give you the value of C of 3.5, you can think of this as finding the slope from 3 to 4. So C prime of 3.5 is going to be C of 4 minus C of 3 all over 4 minus 3. Which is the rate of change from 3 to 4. So because they give you the values of C of 4 and C of 3 in the table, you can plug these in. And when you solve, you get 1.6 ounces per minute. So if we just recap on what we just did, because they were asking for C prime of 3.5, they were asking for the rate of change, or the slope. So we took the values of 4 and 3, which were provided in the table, and found the slope between them to find this value. And just to clarify how we got these units, because the numerator is measured in ounces and the denominator is measured in minutes, the answer will be in ounces per minute. So 1 point would be given for the approximation and the other point would be given for the units. So part B asks, is there a time t between 2 and 4 at which C prime of t equals 2? Justify your answer. So with part B, in the original problem they said that C was differentiable, which means that it must be continuous also. If you have a function that's both differentiable and continuous, that means that you can use the mean value theorem. So if we do f of b minus f of a all over b minus a, then we can see if c prime of t equals 2 somewhere in this interval. And we find that by the mean value theorem, there is a value of c prime of t that equals 2. So in this problem, 1 point would be given for using f of b minus f of a all over b minus a, and the other credit would be given for using the mean value theorem in your justification. So in part B, we wanted to find if C prime of t in the interval from 2 to 4 at some point equaled 2. And by using the rate of change of f of b minus f of a all over b minus a, we found that it did equal 2 sometime in the interval. Part C says, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 integral from 0 to 6 of c of t. Using correct units, explain the meaning of this in the context of the problem. First, it is important to understand what a midpoint sum is. So the midpoints in this table are at time equals 1, 3, and 5. So the width of the rectangle from 0 to 2 is going to be the difference of 2 minus 0, which is just 2. The height of the rectangle is going to be the y value c of t at point 1, which is the midpoint between 0 and 2. The width of the second rectangle is going to be 4 minus 2, which is also 2, and the height is going to be c of 3. The width of the third rectangle is 6 minus 4, which is also 2, and the height will be c of 5. When solved, you get an answer of 10.1 ounces. The second part of this problem asked what the meaning of 1/6 integral from 0 to 6 of c of t means in the context of this problem. You can think of this function as f of b minus f of a all over b minus a, which would be the average amount of ounces from time equals 0 to time equals 6. on midpoint sum, approximation, and interpretation. So we found the midpoint sum by using the table, and then we realized that this is similar to f of b minus f of a all over b minus a. This finds the average amount of coffee in ounces in the cup from 0 to 6 minutes. Part D says the amount of coffee in the cup in ounces is modeled by a function b of t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So in part D, they give you a function b of t, which they tell you is measured in ounces. Now this is not a rate, so we need to change it into a rate by taking the derivative. So the derivative of 16 is 0 because 16 is a constant. The derivative of negative 16e to the negative 0.4t can be found by using the product rule. We find that the derivative of b of t equals 6.4 e to the negative 0.4t. The problem asks us to find the rate at which the amount of coffee in the cup is changing when t equals 5. When we plug in 5 for t, we find that the rate at which the amount of coffee in the cup is changing is 6.4 divided by e squared ounces per minute. Points for this problem were given for finding b prime of t and b prime of 5. Looking back at the whole problem, it is important to understand the difference between finding the average value and the average rate. The average rate was found in part A, where we did f of b minus f of a all over b minus a. In part C, we found the average value by using the midpoint sum. In the problem, you can immediately recognize if they're asking for the average value or the average rate. For example, in part A, they were asking for c prime of 3.5, so this was a rate. In part C, they asked for 1/6 integral from 0 to 6c of t, which is the average value. The mean value theorem and the intermediate value theorem are also important. In part B, we use the mean value theorem to find if there was at least one time when c prime of t equaled 2. It is also important to recognize the difference between an amount and a rate. In part D, they provided us with an amount, so we had to change b of t into b prime of t to find the rate.